Good morning, everyone. In this lecture series, we are going to discuss about the nodal analysis. In the previous lecture, we have discussed about the voltage current source transformation. So in this, we are going to see about the nodal analysis. So what do you mean by nodal analysis? We are going to determine the voltage at different nodes. Already we have discussed about the nodes in the previous video. So from that we have to calculate the voltage at the different nodes. So in this diagram we are having two nodes, that is represented as N1 and N3. So here the 5 ohms is connected to the N1. Now between the N1 and N3 the 10 ohm has been connected. Suppose once the voltages are known, branch currents can be easily calculated. Now the node 2 has been connected with this 30 and 10 ohm. So there we have to determine the voltage. This is termed to be as nodal analysis. The next one we are going to see the basic principles. So in this basic principle, we are going to see how the nodal analysis is based on which laws. So here we are going to see the nodal analysis is based on Kirchhoff's current law. So here the algebraic sum of the currents that is leaving or entering a node is 0. Here the relationship between the KCL and KVL, that is nodal analysis, is here the algebraic sum of the currents leaving. So here the leaving current will be, that is I2, I3 and I4. The incoming current will be I1 and I5. So this is termed to be as the Kirchhoff's current law. Here we are going to see what are all the steps in the nodal analysis. So we have to identify all the nodes in the circuit. So here the first thing is we have to choose a reference node and we have to assign it as 0 volt. The next one, we have to assign the node voltages for V1, V2, and the remaining nodes will be with respect to that of the ground. So here the resistors R1 and R3 has been connected. So across this resistor we have to find out the node, that is V1, R3 and R5. We are going to calculate the node V2. The next step, we have to apply the KCL at each non-reference node. So we have to form the simultaneous equations from the HCl, and then we have to solve the equations to obtain the nodal analysis. Suppose if we apply the KCL for node 1, that is V1 minus E divided by R1 plus V1 by R2 plus V1 minus V2 divided by R3 is equal to 0 for the node V1. If we apply for the node V2, it will be V2 minus V1 divided by R3 plus V2 divided by R4 plus V2 divided by R5, which is equal to 0. The next one, we are going to determine the current sources. The current sources, it is directly included in the KCL equations. So here the direction of the current must be carefully considered. So that is the main thing in this. The next one, we are going to find out the super nodes. So here we are having the two nodes, and from these two nodes we are going to calculate the voltage source between the two nodes, and we are going to create a super node enclosing the voltage sources. So after that we have to apply the KCL to the super node. Then we are going to see what are all the advantages of the nodal analysis. Efficient for circuit with many current sources, and it requires fewer equations than mesh analysis in many cases, and it is well suited for the computer based circuit analysis. So these are all the advantages of the nodal analysis. The next one is the limitations. So in the limitation, it becomes complex with many voltage sources, and the super node handling requires extra care. And the next one will be the mind map for this session. So we have seen what is the basic principle that we have used in this nodal analysis, that is KCL, that is Kirchhoff's current law, and what are all the special elements we are using, that is current sources, voltage sources. So the current sources, it is nothing but direct in KCL, direction consider. The voltage sources, it forms the super node, and we are going to apply the KCL and the voltage equations. What are all the steps we have seen in the nodal analysis, and what are all the advantages? For example, it is good for the current sources, and there will be fewer equations, and it will be computer friendly. So while coming to that of the limitations, it is tricky with the voltage sources, and it will be the super nodes or complex. Thank you.